This week on Hacker News and the other programming websites, there were two articles that caught my attention, mostly because they were so diametrically opposed. And I was trying to think of why I felt that way, because the premise of the two articles was pretty straightforward, and I think to a certain degree, most people agreed with the high level points that were raised. Maybe not the whole content or the conclusion of the articles, but the general idea. So the two articles that caught my attention is probably that this one was from Dan Lu, why there's no reason software to be slow anymore. General gist of the argument, there is now with LLMs, it's very easy to find positions and go for the hard, quote unquote, hard things optimize compared with before. Whilst maybe it's not necessarily a solved problem, it is something that is much easier. These include time compilers and also it's about the WASM and JavaScript side of things. Find it where these kinds of experiments which were before way too difficult to optimize and improve are much easier to do. On the other hand, there was this article which I thought was very curious, which was about OpenTelemetry isn't going so well, and the high level ideas behind it was that whilst there are vendor SDKs, the actual open source one, there's a lot of pressure going on open source one. There's a lack of maintainers or people merge the code, and there's also a drop in amount of mergers that are being made and also issues. And these two things are two different types of software. They're both done by software engineers, and both done by developers, as we would describe them, but they're very different in the nature of the problems that they're solving. And I tried to think about like what's the best way to frame it. And I think the framing that I'm going for, which is still something forming in my head, is there's a difference between something that's like more of a quote middleware, perhaps not middleware in the formal sense, but it's software that is between other pieces of software. Something like OpenTelemetry. Telemetry is a timely one because it's something that almost also a lot of software uses tracking observability. And that kind of software resembles many things that are in the SaaS world, startup world, like software that people purchase in order to do their job. Stuff like Atlassian's, like Jira and Confluence and so on, is an example of that kind of software. And I do believe that kind of software has been getting pretty horrible for a large number of reasons, and we're going to touch on that. And I think the other counterpoint to this is probably this general idea that computers have been getting faster, internet has been getting faster, but really the web page loading time has not changed at all since basically forever. It's almost as though with faster internet, people make use of the extra bandwidth to host more things, whether it be images, videos, and so on. And there's many conversations on this point as well. One of the challenges here is that there is that belief that as software has gotten cheaper to make, yeah, the void is going to be filled up with something. The typical example here is going to be like Electron apps. Before desktop apps, not many people made desktop apps because it was difficult to make, and oftentimes computers had limited memory. Now, when memory is relatively cheap on computers and download speeds or like binary sizes don't matter as much, you can create these large complex Electron apps very easily, so long as you have some React knowledge and the like. And it may not be the most efficient app, it may be a pretty slow app, but you can do it. And that's like what the tooling has brought even before LLMs came into the picture. Now that LLMs are here, that has even accelerated because now people can now just vibe code apps and host them, whether they're desktop apps or. Now, why is it slow still? And probably the biggest reason I think is that people's default expectations of UI and UX has fundamentally changed over the years. When we were predominantly using, say, a desktop application, you would expect the desktop application to be very, very fast. Even when you were using a phone app, you would expect it to be very, very fast. What changed was when the internet came along. All of a sudden, when internet came along, Android app, and maybe you click on like a Java applet or something like that, all of a sudden it took a very long time to load. And I think people just learn to live with that. Same with like dial-up internet and so on and so forth. That kind of era has sort of translated to today's era, where we are talking about LLMs and agents that take seconds to execute a task. And even in the most recent MCP uh, announcement about how they're transforming MCP in the roadmap, there was an acknowledgement that there is this kind of like task-based system that people are relying on more and more. So that means that there is this default expectation that has got even further away from the need to create fast applications. And I think like this nature of like user experience and developer experience as well, like developers using coding apps, has definitely changed what people perceive to be good software, what people perceive to be important to software as well. There's of course this dependency picture, which is from XKCD, and this is very reminiscent of the issues that OpenTelemetry is having. You just have some random person maintaining a really large project that many people rely on. OpenTelemetry is used basically in every single web service that you can imagine, whether you're using Grafana or something else. Almost everything supports OpenTelemetry or is built on top of OpenTelemetry. And in that article that I showed, and I will quickly scroll down just to show you the important parts. They did show those exact metrics that I was trying to explain. So for example, in this picture, I'll try to make bigger, and I can't in this mode. Yeah, I'll have to. That's not the right picture. It is the one below it. They have showed that there is this line that's trending downwards, as I was mentioned, for commits per month, human versus bot, and also PRs merge, bot filter, issues closed. So that's the trend that they're showing, and the key number that came out from this blog, which maybe I'll try to find, which is from this table, is just to highlight the concentration risk, I suppose, like the bus factor, if you like, of certain OpenTelemetry applications, or like the programming language bindings. This is important because OpenTelemetry itself is a spec, but each of these languages are generally maintained separately, and they are maintained separately because you can see the top mergers in these roles are not the same people, and this means that there is definitely a level of risk, and not only risk but also compliance to the OpenTelemetry protocol. So you can see from all of these are big languages, right? With JavaScript and Python, for example, probably being the two most popular languages, have a concentration risk when it comes to OpenTelemetry. Similarly, there are issues with, well, the ones at the top as well, Kotlin and CPP. Kotlin being one of the biggest enterprise languages working JVM. And I think this just spells the complexity of software and management. It's not just having funding to do open source. It's just also there's a lack of people that are maintaining this software. So you either have a situation where people are just going to rely on AI to maintain a lot of software that is extremely critical, or that something else is going to give. It's hard to say what's going to happen, but I think there's going to be a lot of interesting discussions in the future about this challenge. So the other challenge is, as I alluded to, this kind of middleware idea of software where you're reliant on like SaaS providers. A big one here is definitely going to be the recent scenario with Anthropic. There was this tweet that went around. It was about how even if you specify high or the model says high, the model is actually doing like low reasoning instead. And yeah, the thesis on X or Twitter is that they're doing some kind of A/B test just to see whether people will spot it. And this comes off the heels of like Anthropic also doing watermarking and all other kinds of things where people are coming up with like, rather they're speculating on why there's such a big change in the performance of Anthropic models. We're saying that 4.6 was probably the last good one, whereas all the other ones afterwards maybe were just vibe coded or like was relying on Mythos or Fable or those kinds of big models to check itself. So it's hard to say what's going on, but this seems to be a very common theme. And that exactly spells why software is going in this direction as well, right? So we have this challenge where where our providers are purposely making software worse. So software is not getting faster, or if it's getting faster, it's like an illusion in this particular scenario. And AI to a certain degree is to blame, or rather, not so much AI, but rather demand of a particular software and also the fight for profits. So that's why software is not getting faster, is because that's not the goal. It's possible. So I think that's really the point that I'm trying to make. Yes, if people have a very specific workload or a specific standalone piece of software that doesn't rely on other things, yeah, I do believe that kind of software will continue to get better and better with AI. There's going to be lots of optimizations to find. And when you don't have dependencies, it makes it very, very easy to deal with, right? However, if you're dealing with pieces of software that relies on servers or cloud environments, or maybe you're just some kind of like software glue between two services, software in that kind of nature will probably just only get slower and slower. I think that the goal there for many businesses is not to provide you the best user experience or developer experience for that software, but rather it's going to be around how do we make, fortunately, quality of software not necessarily the most important thing. In fact, to make the most money for you, sometimes it means giving you worse experience, right? Case of like LLMs and tokens, maybe it's to get you to spend more tokens. Maybe if they make the thing slower, then they can get more. Then the value like of your code subscription is worth less, right? Because you can't get throughput. So these kinds of things we have to think about. Why does someone have to do it? And making good quality software is always the goal. Sometimes, in order to make some money, it's important to make software work. The idea behind it. So those are my thoughts. We have AI that's coming in, and yeah, in some cases, make stuff great. Cases gonna make stuff